Hello. In this lecture, we will be looking up integration of trigonometric functions. So first, we'll be looking up what integration is, what are the other names of integration, when is it that you actually integrate, what is the reverse process of integration, and what was actually the originating point from where this process started. After this, we'll be looking up the process of differentiation. We will come to a derivative, then we'll come to the antiderivative, that is the integral, and understand this complete process. After this, we'll be talking about different type of trigonometric functions, which all will be integrated by different methods. So whenever you talk about a trigonometric function, a normal function, be it in the numerator, be it like a rational function, comes to your mind. But here in integration, when we talk about different trigonometric functions, remember all of these have different methods to find their integrals. For that matter, one thing you should remember, that is something which is very special about integration. We have some formulae, and whatever functions we get whose integrals are to be found out, they have to be somehow or the other turned and twisted in the form of formulae that we have. And this process thus becomes very enjoyable. So there obviously can be some such sort of functions which you are not able to turn and twist and bring it in terms of the formula that you already have in existence, and as such you will not be able to integrate those functions. And that is why there are few functions which are integrable and there are many functions which are not integrable. Right? So let us now start the process of trying to understand from where this story started. For that matter, if say we talk about a function f of x, this is a function in the independent variable x. That means when you keep different values of the independent variable x, correspondingly you will get different values of f of x, that is the function in x, which is also said to be the dependent variable y. Now further, we can have it to be, say, some x cube plus 27 sine x plus, say, some 73, right? So this is a function x. As the value of the independent variable x will vary, correspondingly you will have that the dependent variable y will also change. Now comes the process of differentiation. So if we now differentiate the above function, what we actually do is we are actually trying to find out, we'll rather write differentiation. So we are trying to find out the process of finding out the change in the value of the dependent variable with respect to the change in the value of the independent variable when the change in the independent variable is infinitesimally small. For that matter, this is written something like this, that is, if you talk about a function, say some f of x, and now if you want to find out the change in the value of this function, right, and if you divide it by the change in the value of this independent variable, when you say that the change in this independent variable is infinitesimally small, then you call this process to be differentiation. Now better, this is written like just d upon dx, where d actually shows that this change in the value of the independent variable is taken to be infinitesimally small, right? And here this sign, that is delta x, that is change in the value of x is infinitesimally small, is represented by just writing an arrow and showing that it is approaching 0, right? So this is thus how we find out the derivative, and this is written like d upon dx of the independent variable y, right? Obviously, as y is f of x, so we can even write this as d upon dx of f of x, and in representation this is written like f dash x. So this, children, is what differentiation is. Now we have a function at hand, and let us quickly look up what the derivative of this function is going to be. So if we talk about f dash x, for this case that we've been given, so we can write the derivative by using some formulae, which first I like to tell you. So if we talk about the first formula that is involved here, that is d upon dx of, say, some x raised to the power n, and that is going to become equal to n times of x raised to the power n minus 1. The next formula that is involved here is to find out the derivative of a constant which is multiplied with a function, right? And this is going to become equal to a times of what? A times of the derivative of the function, right? That is a times, this is going to become equal to a times of d upon dx of what the function f of x is, right? Okay, now after this we have the next formula, that is we will be talking about the derivative of sine x function. Now this is a trigonometric function and its derivative is equal to cos x. Further than after this, we also have the derivative of the constant, right? Like 73 is a constant and the derivative of the constant is 0. That is because a constant doesn't change even if the value of the independent variable changes. Like if you have f of x to be equal to 43, whatever value of x you keep, the value of the function will always come to 43, and that is why change in the value of the function, that is the constant function, is 0 when there is some change infinitesimally small happening in the value of x, and as such the derivative comes equal to 0. Now children, after having all of these formulae just before us and knowing all of these formulae, now we can very easily find out the derivative of this function. As such, the derivative of f of x, which is f dash x, will become equal to 3x square, that is n, which is 3, times of x raised to the power n minus 1, that is 3 minus 1, that is 2, plus 27 being a constant will stay outside the process of differentiation, and the derivative of sine x will become equal to cos x, right? And to that then you will be adding 0 as the derivative of a constant is 0, and since 0 is additive identity, so finally the derivative will become equal to 3x square plus 27 times of cos x, right? That's it, because 0 being additive identity will quietly vanish, right? So this is the derivative, and now we come to the process of integration. So if we do an integration, then what is going to happen? On integration, as integration is said to be the reverse process of differentiation, and that is why we find out integrals, or we find out the antiderivatives, and that's why we also call it to be primitive. Why? I'll tell you just now. So by the process of integration, we actually reverse the process which we did by differentiation. In differentiation, as you must have seen by these formulae, we have actually changed what the original function was. Now this is the derivative. This is not the same as the original function f of x, right? This is separate, and this is f dash x. So if we integrate, we will be able to get to the original function f of x back, right? So this actually is integration. So let's now look it up. So if we talk about integration of, say, some differentiated function f dash x, which is also multiplied with dx, which is an infinitesimally small length, right, which is the width of the small elements that we take in finding out the area under the graph of any function, right, which in times to come in detail we'll be discussing in definite integration and in application of integrals. So just hold your guns till then, right? We'll be discussing it in detail then, right? So at the moment, just remember that it is always customary to write dx, right, when you multiply it with the derivative of a function where the independent variable is x. If suppose the independent variable would have been, say, some t, then here this would have become f dash t times of dt. Okay, now children, when we find out the integral, we will get the original function f of x back, right? And to that is going to be added the constant of integration. Now, from where did this constant of integration come? That is what I'll tell you. If you have a constant and when you differentiate it, you got 0, and as 0 is additive identity, it quietly vanished into thin air, and now you won't be able to see it in the function, right? If you talk about this to be the derivative, then in this, are you able to see the constant that was there? Right? How will you be able to imagine whether it was 73 or 7.3 or probably 730, right? And that is the reason why you just write a plus c, right, which is in memory of the constants which were lost in the war of differentiation, right? So these are those flowers which you keep on the grave of the constants which have passed away in the process of the war in differentiation, right? So we now have here this to be what integration is. Now I'll just quickly repeat all that I told you, so that if there is any speck of doubt anywhere left and you're studying integration for the first time, everything is perfectly clear. So till the time I am explaining, make sure, children, that you don't pick up your pen, right? If you pick up your pen and you start writing something, then your concentration will become diffident, and then deviating in a different direction, you will not be able to understand what I'm trying to convey to you from a distance, right? So make sure that you're seated on a table and chair, you're seated straight, and you're focusing exactly where my pointer is, sitting at a secluded place, so I can assure you, you will be able to understand everything. And this is primarily the reason why I also give you a second explanation, so that everything is crystal clear, right? Okay, so let's try and understand this. If we talk about the integration of a trigonometric function in times to come is still to be looked up. We at the moment are just looking at what integration is. Then we actually start off from the process of what a function is, that is f of x. It can be, say, some y, which actually shows that this is a dependent variable. When we keep different values of x, correspondingly we'll get different values of y. Now differentiation of this above function will be change in the value of the function or the dependent variable with respect to the change in the value of the independent variable when the change in the independent variable is infinitesimally small. Remember, this is actually just like a small triangle, which is delta, a Greek alphabet, right? And generally speaking, it represents change in, right? So if we talk about d upon dx of y, right, this is how you write the derivative of the function y, which is a dependent variable. Or in other words, you can even say that this is the differential coefficient of the dependent variable with respect to the independent variable x, right? And this is also written like d upon dx of f of x, as y was actually f of x, right? And further, another way to represent it is f dash x. So here we have a function. We can easily find out the derivative of the function, and now when we find out the derivative of the function, we require some formulae, because the function has an algebraic function, the product of a constant with a trigonometric function and another constant function. So we should be knowing the formulae of each of these functions. So when you have the derivative of x raised to the power n, then that becomes equal to n times of x raised to the power n minus 1. This is the first formula. Now the next formula that we have applied here is d upon dx of a times of f of x. That means when there is a constant which is multiplied to a function whose derivative is to be found out, then that is equal to the product of the constant multiplied with the derivative of the function. Now if suppose we have a trigonometric function like sine x and we've got to find out the derivative, then that becomes equal to cos x. The derivative of a constant is 0, and I reasoned this out to you that if suppose we have a function f of x which is equal to 43, right, then whenever you change the value of x, you'll feel that there'll be a change in the value of the function, but nothing is going to happen because its value is fixed at 43. That is why in the process of differentiation, there is no change in the value of the dependent variable. It will remain to be 43 earlier, 43 later, right? And as such, the change will become equal to 0, right, with respect to any change in the value of the independent variable. And that is the reason why the derivative of a constant is 0. Next, after finding out the derivative using these formulae, which now we can do, we directly write here the derivative of x cubed to be 3x squared, because n times of x raised to the power n minus 1, that is 3 minus 1, so this will become equal to 3x squared. Further, as there is a constant which is multiplied by a function, so the constant will be kept outside, and you write the derivative of this function sine x, that becomes equal to cos x, and the derivative of this constant is 0. And as 0 is additive identity, so it will quietly vanish into thin air, and as such you are just left out with 3x squared plus 27 cos x, which becomes the final derivative. Now children, if we integrate this derivative, then we get the primitive or the original function back, right? And as this process is just the reverse of differentiation, that's why it is also known as finding out the antiderivative, right? So this is the process of finding out the antiderivative, that is integration, or the process of finding out the primitive, that is the function which was already there originally, that is f of x, right? And why do we write this constant of integration plus c? That is because we have lost some constants in the process of differentiation, and in place of these constants, actually we have this plus c, which represents the constants which have been lost in the process of differentiation. Now what is this dx? Dx actually is the width of a small element which is infinitesimally small, into which area under the graph of a function when it is graphed in xy plane, right, is to be found out. All of this I will tell you further in detail when we will be discussing definite integration and also application of integrals. Now next, after we have this, we will now come to the integration of trigonometric functions, towards which this lecture is devoted. So children, we can be having different type of trigonometric functions, right? For that matter, when normally you talk about a trigonometric function, you are actually faced with the fact that probably it will be a function like sine cube x, or probably sine x upon cos x plus tan x, right? Like it is something which is in the numerator, or probably there is a rational function, right? This is actually what comes to your mind. But here actually what happens in integration is, for every function there is a different way to integrate it, because we have to somehow or the other turn and twist the functions to be in the form of the formula that we have, right? And then we can apply the formula. So there are a few functions which are not integrable. That is because they cannot be brought in the form of formulae that we have, right? So how do we bring these trigonometric functions in the form of the formula that we have is what we're going to learn here. So one of the functions that is trigonometric and is to be integrated is, say, a simple function like sine x, right? And it can be multiplied by a constant, say some a. So obviously here what you'll be doing is you'll be taking the constant outside and just integrating the function which is sine x, right? After that, you can be having a power function of, say, this independent variable, right? And it, say, is sine square x. So x here is the independent variable, and you have a power function of sine, that is, this is sine of x whole square, right? And for such a sort of a function, you'll be applying some formulae from compound multiple angles and try and bring it such that it is not the square of the trigonometric functions and it's just linear, right? Okay. Now, if you have higher powers, like suppose if you talk about sine raised to the power 7 x, right? So what you'll do is you'll break up some sine and you'll multiply it with 1 power of sine, and further here you will convert this in terms of cos, and then by applying the principles of integration by substitution, you'll be able to deal with it, right? Now, what will you do if suppose you have a function of trigonometry, like suppose if you have 1 upon 1 minus sine x, right? So such functions which can be brought in the form of formulae can be dealt with, right? Others which cannot be brought in the form of formulae cannot be dealt with. So if you talk about any trigonometric function which is a rational function, right, it is not necessary that you'll be able to solve it and bring it in the form of a formula. For that matter, that also applies to a function which exists just in the numerator, right? Now children, after this, if suppose there is some number which is multiplied with, say, the independent variable, then there is a direct formula by means of which we can find out the integral of such a sort of a function, right? Obviously here we will be applying integration by substitution, and using it we will then be able to get to the integral of the function, right? Now after this children, if say we now have a function which is, say, a linear function of sine and cos, and in the denominator, right, like suppose you have some 4 which is divided by, say, some 4 sine x plus 3 cos x, right? Then there are a few ways by means of which we can do the sum, right? And here we'll be actually looking up a way by means of which we can deal with such sort of sums, although there are other ways by means of which you can deal with this sum, right? One of the ways is that we take tan x upon 2 to be equal to, say, some theta, or say some t, and then we write all the functions in the form of tan x upon 2, right? That is in the form of t, and then we come to the antiderivative, as now it will be able to be written in the form of a formula, and then you'll be able to integrate it. Now after this, we can even be having power functions of such linear functions which are there in the denominator, right? Now you can be having, say, something like some 17 which is divided by, say, some 4 sine x plus, say, 25 cos x, which is raised to the power 3, right? So such sort of functions can again be dealt with by using a concept of converting all of this in terms of a single trigonometrical ratio, right? And then bringing it over to the numerator. Then probably there is a formula, or you'll have to apply some concept like integration by parts, etc., to be able to deal with such sort of integrals, right? So here we'll just be looking up what to do in such sort of functions, right? Now next, after this, we have a function which is there in the numerator as well as in the denominator. So if, say, we have some 7 sine x minus 2 cos x, right? And if, say, it is divided by 2 cos x plus 3 sine x, right? So like I told you, there is a way where we take tan x upon 2 to be theta and we deal with it. There is another way by means of which we can do it. We can write the numerator to be equal to some small m times of the denominator plus small n times of the derivative of the denominator, right? I know all of this is becoming pretty overwhelming, but don't worry, I'll be keeping a class for each of these in times to come, right? And then you can look up the whole series and make yourself well equipped with the integration of trigonometric functions. If you're liking all of this, make sure that you want to see other lectures which are also of this type, because not just will this help you in your present academics, but in times to come, this is also going to help you in the competitions that you want to beat, to be studying at a very nice institute, very nice university, and in times to come also that will help you in getting employed, right? And that is why, children, I take you through a journey which is joyful, right? And it takes you from education to employment. I actually provide you mathematics education, not just of your class, but even of the classes which were before, right? In which you require to be strengthened. And then further, I also provide you some knowledge with the help of which in this subject you'll be able to get yourself employed. So if you're getting interested, you can directly join me in taking you people through this journey, where I'll ensure that everything is clear. You are able to understand the subject, you're able to comprehend in the subject, and you're also able to analyze as to how you do the sums and how you take your career through a graph which is ever rising, and your success will actually give me a lot of happiness. Okay, let's get back here. Before that, let me quickly tell you how do you actually get in touch. So there actually is a form which is there in the description of my channel, or probably in the bio of my channel. You can find it out, right? It is there in both the places. You require to just click on it, fill that simple form, just give me a few data like your email ID, and then you'll find me getting back to you and helping you out with all the support system that I have, and your problems that you will write in that form will be cleared for life. I can assure you that. Okay, now we can be having another type of a function that is, say, some cubic function which is only specially applicable to such functions. Like suppose if we talk about cosec³x. Now for such a sort of a function, the way is that we treat it like cosec x into cosec²x. That means a function which is less integrable multiplied by a function which is more integrable, and then we treat it like two different functions and we apply integration by parts to be able to deal with it. Like I told you, each of these I'm going to discuss, and I'm going to let you people know how trigonometric functions can be dealt with. So there's nothing to be overwhelmed. I've just given you a briefing as to what different type of trigonometric functions you can be having and how you have to deal with different functions in a jiffy, but obviously that's going to happen in detail in times to come. Okay, at the moment, children, now we come over to actually the gift that I want to give you people, that is this sum which I want you people to be able to deal with, right? And here we have the sum which is before you. So I want you people to find out the integral of this function, right? That is the primitive of this function, right? First, at the moment, by applying all that you know, right? And in times to come, when you are not able to do it, make sure you look up this solution, right? And then there is a second explanation. Make sure till then you don't pick up your writing material, and after that you do the sum once, and then you would have learned how to do such sort of sums for life, right? So at the moment I will give you a little time for trial. You can enhance this pause by taking some 4-5 minutes where you can try out the sum. Why is this something which is customary? That is because whenever there is any sum before you, you should first try it out. You should first try and check whether you actually can do it. If you just keep taking things, then you would be depleting your confidence, and I want your confidence to surge high so that you can pick up new challenges and succeed in them. Okay, now children, we have this question, that is, find the integration of the trigonometric function. So here we've been given a trigonometric function, and since we've got to integrate, right, it automatically means that if we are to find out the integral of this, first we have to write the sign of integration, that is this sign. And then here, as in the numerator we have nothing, so obviously 1 is going to get multiplied with dx, and then children, in the denominator we already have been given 2 sine x, right, to which is added 3 cos x, right, and there is a whole square of this, right? So next, children, here we get to see that there are trigonometric functions in the denominator, and obviously this is a whole square function. As such, when you expand it, this will actually become a trinomial, and there'll be more problems that you have. For that matter, always remember, if you have a function which is rational, right, it is best if you have the least number of terms in the denominator. Best obviously will be if you have a monomial, right? You can be under better situation, under better conditions if you have a binomial, right? That means best will be a monomial, right? Next best will be binomial, next best will be trinomial, and obviously you always have to try so that you can get it to a monomial and finally vanish it so that everything can be brought to the numerator, or you can write this in the form of a formula and then you are able to integrate it. Okay, so let's come to this. Now here we can't obviously expand this, otherwise, you know, what's going to happen is it's going to become pretty dirty a function and we won't be able to bring it all together. So our task is actually to bring it all together, make it really short, right? So the first thing that you can do in this is, if you have a trigonometric function in terms of sine and cos, which is in the denominator and which also has some coefficients, that means there are some numbers which are multiplied, first what you do is you multiply and divide by the root of, the sum of, the squares of the coefficient of sine x and cos x. I'll just quickly repeat this. So if, say, here we talk about root of the sum of the squares of the coefficient of sine x and cos x, so actually we'll be doing 2 square plus 3 square, and whatever comes we'll find out the root of this. So this becomes 2 square, that is 4 plus 3 square, which is 9. So 9 plus 4 will become equal to 13. As such, this becomes equal to root 13, and that is with what you got to multiply and divide this function within the bracket, remember, right? So as such, this is going to become equal to integral of dx, which is divided by 2 upon root 13 sine x, And when I finish, I want you people to answer this question, that why is it that this was required to be done? We could have done without it, but why is it to be done in a mandatory way? Now, one thing, as we have divided by root 13, obviously within the bracket we should have multiplied by root 13, and when it goes out of the square function, obviously it will become root 13 whole square, that is 13, right? So this now is the function, and I want you people to tell me what is the reason that this has been done. That is, why do you require to divide by the root of the sum of the squares of the coefficient of sin x and cos x? Can anybody tell me in class? Yes? No? Just think? Well, let me tell you. If suppose we talk about a function which say is sin x, do remember, for that matter, we can even write sin theta, which is more casual, which is more popular, right? We know that sin theta actually varies between two values, that is -1 and 1. And similarly, if you talk about cos theta, it also varies between two values, that is -1 and 1. As such, if you talk about any value of sin theta, for that matter, if you talk about this theta, it is an element of real number. That means any real value is possible. Similarly, when we talk about the cosine function or the cos function, any real value for theta is possible. And for any real value, if the final value comes to between -1 and 1, for both of these cases, obviously if you talk about this 2 or if you talk about this 3, they are actually not those which are in this range, that is between -1 and 1, and thus we require to bring them in this range. That is, this has been made into a proper fraction, as you can see, right? And whenever you talk about a proper fraction, its value lies between 0 and 1 if it's positive, or 0 and -1 if it is negative, right? And why do you require to do this then? The next question. Okay, this is good that you've done this. So why do you require to do this? Well, let me tell you. If you talk about the first number, we can write it like some cos alpha. And if you talk about the second number, we can write it to be, say, some sin alpha, right? We can assume it, right? So let's now do this. Let us assume this, that we have 2 upon root of 13, which say is some cos alpha, and we have this 3 upon root 13, which can be written to be, say, some sin alpha, right? So this is our equation number 1, and this is our equation number 2. And now if you do this, that is, if you divide the second equation by the first equation, you can even divide the first equation by the second equation, then what you will get is, you will get to see that you have here sin alpha, which will divide cos alpha, right, as we have the second equation divided by the first equation. And then you will get this here to be 3 upon root 13, which is going to be divided by 2 upon root 13. And here you will get to see that root 13 will get cancelled after reciprocation, and this will come to 3 upon 2. And since you have sin alpha upon cos alpha to be becoming tan alpha, as such tan alpha will become equal to 3 upon 2, and there is no problem in this, because tan alpha, that is tan of any angle, varies between -infinity to infinity. So if the value is greater than 1, because 3 upon 2 will become equal to 1.5, there is no problem, right? So now that we have tan alpha to be 3 upon 2, we can obviously say that thus alpha will become equal to tan inverse of 3 upon 2, right? So this is what alpha is. Now that we will be introducing alpha, so as such, now we can now write this integral that we had to be converted to be in the form of dx divided by sin x cos alpha. As remember, 2 upon root 13 has been taken to be cos alpha, plus we have cos x times of sin alpha, right? And further here, what happens is, as there is a whole square, so that's why we'll multiply these two this term with itself to make a whole square here, right, which is represented as this expression whole raised to the power 2, right? Now you people must be wondering that sir was talking about making this a monomial, but sir's actually complicated things. Just wait, I'll show you how I'll make this simple, right? The part of this is 2, and remember this is also multiplied by 13. That means you can write this to be 1 upon 13, with which it is multiplied, right? Now this 1 upon 13 can obviously be taken outside, right? And then that was because it's a constant, and whenever you have the integration of a constant which is multiplied by a function, then that becomes equal to the product of the constant with the integration of the function, right? So 1 upon 13 will go outside, and then now we can write this to be dx, which is divided by sine of x plus alpha. Yes or no? How has this become very much shortened? That's because in compound multiple angles you've learned this formula, and I'll quickly reiterate this. So if say you have sine of a plus b, then that becomes equal to sine a cos b plus cos a sine b, right? Now do you see the magic happening? Very good. Okay, so we've applied this formula, and on applying this formula we now have got sine of x plus alpha whole square. Now remember, if you talk about say something like this, like cos cube x, then that can even be written like cos x whole raised to the power 3, right? So as we have here sine of x plus alpha whole square, so obviously this can be written as sine square x plus alpha, right? So we will now have 1 upon 13, which is the constant outside, times of dx, which is divided by sine square x plus alpha, right? I hope by reciprocal identities you know this, that 1 upon sine theta will be the same as what? Cosec theta, right? So that will become equal to 1 upon 13 times of integral of cosec square x plus alpha, and remember not to forget dx, right? Now here children, we have a direct formula to this, that is that if we talk about integral of cosec square x dx, right, then that becomes equal to minus cot x, right, plus c, as if you remember that if you differentiated cot x, then its derivative was minus cosec square x, right? This is the reason why the integral will become like this. This is the formula, and now we've been able to bring it in the form of formula. That is what I was telling you. If you can bring the functions that you've been given in the form of formula that we already have, then we'll be able to integrate. This is the game, right? So as such, now here you will have 1 upon 13, which is going to be multiplied by the integral of this, which we now know as minus times of cot of x plus alpha, right? And here children, you will add the constant of integration, and you will also write where alpha is equal to tan inverse of 3 upon 2, right? So this is how it is, right? And this thus will become the final answer, right? So all of this I'll just quickly discuss. Like I was telling you, I will give you a second explanation for better understanding so that you don't have any ambiguity. So now children, in this question we've been asked to find out the integral or the primitive or the antiderivative. This is what you learned, right? These are the three synonyms to be saying that we want to find out the integral of something, right? So we've been given this function. Now we've got to integrate this. So we write it in the form of integration. That is, we write the sine, then we write dx, and then we write this function, right? Now as you find that this is a binomial which is whole squared, when expanded it will become a trinomial. So we can't go with that because this denominator will become very large, and then we further won't be able to deal with it. And that's why what we've got to do is somehow or the other we've got to try and make this to be a monomial, right? Now here you get to see that the coefficient of sine x is 2, a number which is greater than 1, right? And the coefficient of cos x is 3, that is another number which is greater than 1. As such, here you'll be applying the rule, that is, you will be dividing this first term and the second term by the root of the sum of the squares of the coefficient of sine x and cos x, that is the numbers which are multiplied with sine x and cos x, right? So here this comes to root of 2 square plus 3 square, that becomes equal to 4 plus 9, that is 13, so that becomes equal to root 13. So we get now 2 upon root 13 times of sine x plus 3 upon root 13 times of cos x, and there is a whole square of this, right? And since you divided by root 13, so obviously within the bracket you also have to multiply by root 13. Now when this goes out of the square, so obviously you will have root 13 into root 13, that is 13 outside. Now remember, this 13 which is there in the denominator can be taken like a constant outside, right? And then you can integrate the rest of the function. Now here, children, we have written what our assumption is to be, that is 2 upon root 13 is to be considered to be cos alpha, and 3 upon root 13 is to be considered to be sine alpha, right? Now if you divide the second equation by the first equation, you will get 3 upon root 13 divided by 2 upon root 13, where root 13 will reciprocate to the numerator and get cancelled with the root 13 in the denominator, and you will get 3 upon 2. Sine alpha upon cos alpha is tan alpha. As such, alpha can be written to be equal to tan inverse of 3 upon 2. Next, now children, what you do is you now get back to the function with the assumptions that you've taken. That is, here you have dx upon sine x cos alpha plus cos x sine alpha, right? In accordance with your assumption, you whole square it, and this is also multiplied by 1 by 13. This 1 by 13 will come outside. As remember, there is another formula that you have, that is, if you talk about the integration of a constant which is multiplied by a function, then that becomes equal to the constant which is multiplied by the integral of the function, right? So this is again a rule which is just the rule, just like the rule that you had in differentiation, right? Remember, in differentiation also we've discussed a similar sort of a rule, right? So next, now we have this constant taken outside, and as this sine x cos alpha plus cos x sine alpha is actually sine of x plus alpha, because we have sine of a plus b to be sine a cos b plus cos a sine b, and thus here we have this to be integral of dx upon sine square x plus alpha, as there was a whole square here. So for that matter, I told you that if you have cos cube x, that can be written as cos x whole cube. So if we have a whole cube, we can write a whole square, we can write this as sine square x plus alpha. Now by reciprocal identities, you know that 1 upon sine theta is the same as cosec theta. As such, this will become cosec square x plus alpha, because there is a square which also has to be taken to the numerator. Now as you know that the integration of cosec square x dx is minus cot x. As such, here you will get minus cot x plus c, which will actually be like 1 upon 13 times of minus cot of x plus alpha. Now this bracket was very important, because from 1 upon 13 you are actually not subtracting cot of x plus alpha, but actually this is multiplied, and that's why this bracket is very important. To this, now you add the constant of integration, and you also define what actually your alpha is, and that is tan inverse of 3 upon 2, a constant. So I hope you people have been able to understand this. Sure. Do you want to know more in the same way? So make sure you subscribe to this channel, and if you've liked it, obviously you can write a small comment as to which was the thing that you liked most about this, and what were your key learnings from this lecture, right? Make sure you also share it with your friends, so that your friends can also be equipped with the knowledge of mathematics, be it for the classes in which they are studying, or probably for the competitions tomorrow in which they have to sit. So they can be banking competitions, they can be the officer entry for the armed forces like Army, Navy, Air Force. They can be other exams like the chartered accountants. They can be any other exams which require such mathematics, because integration is something which is a part of many competitive examinations. So I'm sure tomorrow, not just will you be able to provide yourself education in this class, but you'll also be able to provide yourself with education which is required for employment, which is very much important for your existence. So I am planning all joy for you. So make sure you join this joy journey, where I'll take you from education to employment. Now remember, children, there is a form which is there in the description. make sure you get there and you click on that form link. It's a Google form, right? You fill up some small particulars and then you'll find me getting back to you, as there is also one heading which asks about your doubt. So you can write your doubt there and you'll find me coming back to you and helping you out with your doubt. Okay, one thing more. Now, if you click on the link which is there here in the description, you will find, or it'll be in the first pinned comment, right? You'll find that it'll take you to another lecture, right, which will be in addition to the thing that you studied, which will show you another complicated trigonometrical function which can be dealt with simply, right, if you go ahead with doing the process like I tell you, right? So go ahead and do click on the link and get to that lecture, right, and even learn more, right? Further, if you want me to have live classes for you, because live classes are very entertaining, they are very interactive, and they actually make you do something which actually brings you into action, and you just not keep the things as I'll watch it tomorrow, I'll see it tomorrow, I'll do it tomorrow. It's something which is happening before you, and when you have eye contact with the teacher, howsoever larger be the distance between you and the teacher, when the teacher tells you something who has actually impacted you, then you start doing positive things which starts bringing up positive changes in your life, and then you'll be able to actually surge higher and make me happy. So make sure you do all of these things, and I'll be waiting for your comments. I'll be waiting for you to join my journey, right, where I'll take you from a person who wants to do well in the subject to a person who is very well employed. So bye children, meet you people there, waiting for you people. Bye.